So we have a question over here, and it says, for what values of k does x squared plus kx plus k plus 1 equal 0 have exactly one real solution? And so this is like an example of an advanced question in Algebra 2, college algebra even, and this actually might even pop up in your PSAT or your SAT for all you people out there taking the PSAT or SAT. So what we're going to focus on here is exactly one real solution. So when would K give us exactly one real solution? Well, when the discriminant equals 0, the quadratic will have exactly one real solution. And you might already know this, and I will elaborate on this in future videos. So what we're going to do is we're going to use the quadratic formula's discriminant to find K. So what we're going to do is we're going to remember the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. And so the discriminant is literally this part under the square root. And so when this part is 0, there is exactly one real solution. If it's negative, then there would be no real solutions. And if it's positive, then there are two real solutions. And so that makes sense. It's because it's an x squared equation, right? So what we're going to do is we're going to just take this out here, and we're just going to set it equal to a random letter or variable d. And so d equals b squared minus 4ac. And we're not going to worry about the square root because that just doesn't really tell us anything. It does tell us that actually if it was negative, you can't take the square root of a negative number. That would actually give us imaginary numbers, and that's why there would be no real solutions if the discriminant was negative. So anyway, what we're going to do is we want to find b, a, and c, right? And so what we're going to do is we're going to see, well, what's a? Well, a is going to be the number in front of the x squared term, which in this case is just going to be 1 because there's only one x squared. So that is going to be a. So a equals 1. What does b equal? Well, b is just going to be the number in front of the x term, which in this case is k, positive k. So that's going to be b equals k. And c is just going to be itself, which is k plus 1. So c equals k plus 1. And now we can just substitute all this information into the discriminant and see, well, is it going to be equal to 0 or not? And when it is, that is when we have one real solution. So b squared, which is just b is k, so we just substitute k in for b, k squared, minus 4 times a, which is 1, times c, which is k plus 1. And so now d equals, we can kind of simplify this, k squared, can't do really anything to that, minus 4 times 1, that's just 4, times k plus 1. And we can actually just distribute this negative 4 into the k plus 1 to get d equals k squared minus 4k minus 4. And don't forget to distribute both the negative and the 4 into k plus 1. And so now we can literally just solve this for the values of k that give us one real solution. So when d equals 0, so k squared minus 4k minus 4 equals 0. When d equals 0, that's when we have one real solution, and now we can just solve for k. So what we can do is we can just solve k squared. We can literally just complete the square. K squared minus 4k, and negative 4 divided by 2 is negative 2. You square that, you get a 4, positive 4, minus 4, minus 4, right? So now we literally didn't even change the equation. Plus 4 minus 4, we didn't change anything. So now we're going to just take this in parentheses. K squared minus 4k plus 4 is just k squared, or k, excuse me, minus 2 squared. And that makes sense. If you distribute that, you're going to get k squared minus 4k plus 4. Minus 4, which is just minus 8, equals 0. And so now we add 8 on both sides to get rid of this 8 on the left-hand side. You get k minus 2 squared equals 8. You now take the square root on both sides. And let me just go up here to the top over here. You will get k minus 2 equals the square root of 8, which is, actually we can simplify this. This is the same thing as the square root of 2 times 4. And we know 4 is a perfect square. Square root of 4 is 2, so we can simplify this to 2 square roots of 2. And actually, you take the positive or negative square root. That actually, you have to really focus on that, because that gives you all values of k, not just one value of k. So this is actually going to be the positive or negative. So this is also going to be the positive or negative. So positive or negative, 2 square roots of 2, and now you just add 2 on both sides. And you will get that your values of k that make the expression have exactly one real solution is positive or negative 2 square roots of 2 plus 2. That's one way to write it. Another way to actually write it is to just say, well, I'm going to just say, well, there's a positive and negative version, so you could also say k equals 2 square roots of 2 plus 2. That's one solution. And k equals negative 2 square roots of 2 plus 2. So those are your two solutions that make this expression have only one real solution.